Okay, so when you're adding fractions with different denominators, you got to take some extra steps in order to get the denominators to be the same and be able to add or subtract straight across the top like we did in the previous video, in the previous portion of the lesson. So let's take, for example, 2/5. Let's try to manipulate the denominator for this fraction before we move to the next step, which is adding fractions and having to figure out which one to change. So looking at this fraction 2/5, we see that if we had an image, it would be 2 out of 5 boxes or whatever shaded. Okay, so that means we would have 2 shaded out of the 5. That represents 2/5. Now, let's say we wanted to increase the amount of boxes. If we increase the amount of boxes in the same size strip, that means we will be manipulating the denominator. The denominator tells you how many boxes you have or pieces there are in the whole, and the numerator tells you how many are selected or shaded, right? That's what our 2/5 is telling us about this strip that we have here. Let's say we wanted to change our number of pieces inside this strip to 10 instead of 5. Well, 10 is a multiple of 5, and which multiple of 5 is that? Based on the lesson we learned in least common multiples. 10 is the second multiple of 5 because 5 times 2 is 10. Okay, so we have 10 pieces inside the strip, which is the same size as the previous strip where we had 5 pieces inside that strip. But we can clearly see that the pieces inside the second strip are smaller than the pieces inside the first strip. So let's label them 1/10 because there are 10 total. Okay, so all of our pieces are labeled, and we can say now that our denominator is 10, but what about the numerator? Can we say that that's going to be 2 if we shade in 2 pieces? We got 2 pieces shaded. Take a long look at this new image and compare it to the previous image, the previous strip. If we look carefully, we can almost exactly map the two red pieces that are 1/10 size and shaded onto one 1/5 piece. What does that tell us? That tells us that the 2/10 are not the same proportion or portion of the strip as the 1/5 or the 2/5 are. It's the same portion as a 1/5, but it's not the same portion as the 2/5. So what will make our fraction the same, or what fraction is the same portion as the 2/5? Well, it looks like we have to shade in 2 more. And that will take up the space that 2/5 take up in the original strip. So how many do we have shaded in the second strip? We got 1, 2, 3, 4 shaded in the second strip. 4 out of how many? 4 out of 10. 4/10 gives us 2/5 out of the same size strip. As we can see, this 2/5 does not equal 2/10 when we change the denominator. It actually equals 4/10. How can we show that mathematically? Well, when we had 2/5, right? We wanted to change the denominator to 10, meaning we wanted to increase the amount of pieces in the same size strip to 10. How do we do that? We multiplied 5 by 2 to get 10 because we said that 5 or 10 is the second multiple of 5. So if we look at this new fraction that has 4 pieces out of 10, and we're saying that that equals our 2/5, what do we need to do to 2 to get to 4? Well, we multiply by 2 to get to 4. Those are equal. And so I think that the rule we can come up with is if we want to change the amount of pieces inside of a whole by a multiple of the denominator, then whatever number we multiply the denominator with, we also have to multiply the numerator with to get an equivalent fraction. 4/10 is proportional to 2/5 because it increases by a multiple of 2. So let's say we want to add fractions with different denominators. What do we do? Let's say we want to add 1/10 plus 2/5. Okay, these fractions have different denominators, and that means we can't add them yet. We have to do something by making the denominators the same. Well, let's see, 1/10, 5, 2/5. 5 is a multiple of 10. Let's look at images that match these fractions. As we can see in these images, we're trying to add a small piece, 1/10, to 2 big pieces, 2/5. And these pieces just won't fit together because they're different sizes. So here's some things we need to look at. The second strip with 10 pieces has double the amount the first strip has of 5 pieces. And like we said before, 10 is the second multiple of 5. So the strip with 10 pieces is double the amount of the strip with 5 pieces. So maybe if we split these pieces in half, we'll be able to have 10 pieces in the 1/5 strip. That is the same as multiplying the fraction 2/5 by 2 in the numerator and a denominator to get a new fraction 4/10. Let's see how that works out. So as you can see, the top strip has now 10 pieces to it. 4 of the pieces now are shaded in blue. Now, they also are the same size as the pieces in the second strip that have 10 pieces. Both have 10 pieces now. So we can now add these two fractions. This is now multiplied by top and bottom by 2, and we got 4/10. Now we can add our 4/10 to our 1/10, and let's see what we get. 5/10. So if we want, we can move this red 1/10 strip up to the now 1/10 strip, which used to be 1/5 strip, and we have 5 pieces shaded. Can we reduce this fraction, 5/10? I think we can. I see 5 in the numerator and 10 in the denominator. 5 is a factor of 10, so we can divide 5 by 5 and divide 10 by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. Okay, so our new fraction, 5/10, is actually 1/2. 5 is half of 10. We have 5 strips, 5 pieces shaded out of the 10 strips. Half of the strip is shaded. Let's do another example. 3/4 plus 1/2. Okay, so we have 3 out of 4 pieces shaded, and then we have 1 out of 2 pieces shaded. That's 1/2. So that's what this means. Well, these pieces are of different sizes, and it will be hard for us to add them. So let's make 1/2 have the same amount of pieces as 3/4. Can we do that? Yes, we can do that by drawing a line straight across to divide both pieces in half. What did that do? How do we do that? How can we show that arithmetically? So we have 3/4. We want 1/2 to now be a fraction that has a denominator of 4. If we look at the image, this 1/2 turns into 2/4 that are shaded. 2 out of the 4 pieces are shaded now. How do we get 2/4? Well, we multiply by 2 in the numerator and 2 in the denominator, and we get 3/4 plus 2 times 1 is 2, and 2 times 2 is 4. Now we can add them. 3 plus 2 is 5 out of 4. 5/4. Now you might be wondering, that's an interesting fraction. Well, let's look at it again. We got 2 boxes with 4 pieces. 3/4 were shaded originally. And then we're adding 2/4. In this first box, there's only 1/4 left. So we need another box to shade another piece that's the same size in. And that gives us 1, 2, 3, 4, 5. So this image or this diagram shows us that we have more than a whole. The whole would be 4 out of 4, but we have more than a whole, 5 out of 4. Let's do some subtraction. 4/7 minus 2/3. Okay, this one is going to be a little bit trickier, but you'll be fine. So when we are subtracting fractions, we always have to make sure the denominators are the same, still there. Our denominators are 7 and 3. Is 7 a multiple of 3? Close, but not quite. 6 is a multiple of 3, but 7 is not. 6 is the second multiple of 3, and 7 is not a multiple of 3. So in this situation, what we have to do is find the least common denominator, which would be the least common multiple of the denominator. Same thing. So let's list out our multiples of 3 and 7. 7, we got 7, 14, 21, 28, 35. 3, we have 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. That's that Schoolhouse Rock song. I'll let my students listen to it here and there. So the question is now, what multiples do these numbers have in common? So we see that they have 21 in common. Anything else? I actually don't see anything else. And the next question would be, what's the least common multiple? And so since 21 is the only common multiple out of both of these, then 21 is it. So now that we know that 21 is the least common multiple, of 3 and 7, we can now figure out what we can do to make our denominators 21. So let's just put them as 21 here, and we need to manipulate the numerator of both fractions to make them proportional to the original fractions when the denominator is 21. So how do we get from 7 to 21? Well, 7 times 3 is 21. If we look at our list of multiples, 7 is the first multiple, 14 is the second, and 21 is the third multiple. So 7 times 3 is 21, and then we do the same to the top. 4 times 3, that'll give us 12. Then we look at 3. What do we do to 3 to get to 21? Well, we look at 3, 6, 9, 12, 15, 18, 21. 21 is the seventh multiple of 3. So we multiply 3 by 7, 2 times in the numerator by 7. 2 times 7 is 14. So our new fractions that are equivalent to our original fractions, 4/7 minus 2/3, the new ones are 12/21s, 12/21 minus 14/21. Okay, now we're going to subtract. Remember, the denominator stays the same. The numerator is all we need to subtract. We got 12 minus 14. 12 minus 14 is actually negative 2. So our new fraction is negative 2/21. That's a weird word to say. And there you go. You have the answer. Now you can move on to the knowledge check and test your knowledge to see if you really understand. If not, you can always go back to the examples, the explanations in this video and try again. If you really have questions, please email me because I know that this is one of the concepts that a lot of people really get confused on. So I really understand what you're going through.